Now we are going to look at other measures of dispersion, that is measures of position. So the measures of position, we are going to look at three things, that is quartiles, deciles, and what? Percentiles. And so with quartiles, anytime you hear the word quartile, it means what? Out of 4. Decile, it means what? Out of 10. Percentile, it means out of 100, right? Okay, so here we mean first quartile. When you hear first quartile, it means 1 over what? 4. First quartile is 1 over 4. The next one is second quartile, that is 2 over 4. And the third one is third quartile, that is 3 over 4. We don't have fourth quartile. We don't have 4 over 4. So the least is 1 and the highest is what? 3 over 4. The same thing applies to the decile. So that is 1 over 10, 2 over 10. That is second decile. So we get to the 9th decile. We don't have 10 over 10. Okay. Then when you come to percentile, we have 1 over 100, 2 over 100, 3 over 100 as our third percentile, like that. So we get to 99th percentile, right? So these are the things that we are going to look at. They are all measures of what? Position. Okay. So with quartile, we'll be looking at some items under quartile. One is what? Interquartile range. Interquartile range. One is interquartile range. And so when you hear interquartile range, this one is talking about what? Quartile, and this one is talking about what? Range. And you know how do you calculate for range? That is your maximum or the highest minus the lowest, right? And when you check from the quartile, which one is the highest? 3 over 4 is the highest, right? Then the lowest is what? 1 over 4. So it means before you get interquartile range, you have to calculate for what? Your Q3, that is the third quartile. Then you subtract your first quartile from it. So Q3 minus Q1, that is 3 over 4 minus 1 over 4. So you calculate for the third quartile, then you calculate for the first quartile, then you subtract the result. You don't subtract the fractions. You solve for the third quartile alone. When you finish, you solve for the first quartile alone, then you subtract, you find for the difference. That will give you what? The range, because when you hear range, you know how to calculate for that. Then we also have semi-interquartile range. Semi-interquartile range. We have semi-interquartile range. And so this is what? Whenever you hear the word semi is what? Divided by 2. Any word that is that you have semi attached to it means you have to divide that particular thing by what? 2. So the interquartile range, we know it already. That is Q3 minus Q1. So you have Q3 minus Q1. This is what? Interquartile range. Do you get it? And because we have semi here, it means we have to divide the interquartile range by what? 2. This is what we call semi-interquartile range. Okay, so now we are done with interquartile range and semi-interquartile range. Let's quickly take some examples and solve them. And please don't forget, with all these 3 measures of position, they all have a group data and ungrouped data. Do you get it? So we are going to look at the ungrouped data for all of them. When we finish, we look at the group data as well. Okay, so let's first start with the quartile. Now let's look at how to calculate for interquartile range and semi-interquartile range. Okay, so we know the interquartile range is Q3 minus Q1, right? And the semi-interquartile range is when you divide your results by what? 2, right? So let's pick an example, then we look at it. It's very simple. If you have a distribution or a table or a data set 2, 5, 3, 6, 1, and you are being asked to calculate for interquartile range. First of all, calculate for interquartile range, right? So let me bring everything here so that you know it is Q3 minus Q1, right? Then you divide it by 2 to get semi. That is it. So here, assuming you have a data set 2, 5, 6, 3, 2, right? So you have this. Okay, so if you are being asked to calculate for interquartile range, that is Q3 minus Q1. So if you know it, first of all, it means you have to calculate for your Q3. Do you get it? So your Q3 is equal to 3 over 4 multiplying n plus 1. You bring your TH, right? Okay. Now, n is what? 1, 2, 3, 4, 5. Do you get it? But we said before you start with your calculations, you have to arrange this in ascending order. So ascending order will be 2, 2, 3, 5, 6, right? And how many number of appearances? That is 1, 2, 3, 4, 5. So our n is equal to 5. Okay, so you can say our Q3 is equal to 3 over 4 multiplying 5 plus 1 TH. Okay, so 3 over 4 multiplying 6 TH. So now 3 over 4 times 6 will give us what? 3 over 4 multiplying 6 will give us 4.5, right? To give us 4.5. So our position for the third quartile is 4.5 position, right? So we are going to check from this distribution this position. So the fourth position is 1, 2, 3, 4. So we write our 5 here. This is the fourth position. Plus, now the decimal is 0.5. So we multiply it by the succeeding minus preceding. That is 6 minus 5, right? So now you have 5 plus 0.5 multiplying 1. And this is the same as 5 plus 0.5. And you are getting your final answer to be what? 5.5. So this is the answer for the third quartile. So our third quartile is what? 5.5. Okay. So now let's calculate for the first quartile, since we know when you are calculating for interquartile range is Q3 minus Q1. So we calculate for the Q1 as well. There's the calculation for the Q3. So we come and also calculate for the Q1. And so we know Q1 is equal to 1 over 4 multiplying n plus 1 position, right? So your Q1 is equal to 1 over 4. N is equal to 5. So 5 plus 1 TH. So Q1 equals 1 over 4 multiplying 6 TH. So Q1 equals 1 over 4 times 6. So 1 over 4 times 6 is giving us what? 1 over 4 times 6 is giving us 1.5. So 1.5. We have 1.5 position, right? So here we have the position. Now we are going to look out for this position in this what data set. 1 is here, so it means the first position is 2. You write your 2 plus the decimal is 0.5. You multiply it by the succeeding. The succeeding one is what? 2. So 2 minus the preceding, which is 2. So you have 2 plus 0.5 into bracket 0. So 2 plus 0, which is 2. So there is the Q1, right? So Q1 is equal to 2. So if you are being asked to calculate for interquartile range, you say interquartile range is Q3 minus Q1. So you bring the value of Q3, that is 5.5, minus Q1 is what? 2. So your final answer is equal to what? 3.5. So this is what? Interquartile what? Range. Now if you want to calculate for semi-interquartile range, you say semi-interquartile range. Semi-interquartile range. And that is what? 3.5, the result that you have gotten. Or you can say Q3 5.5 minus 2 all over 2, because semi-interquartile range we divide it by 2. So you have 3.5 over 2. Okay, so 3.5 over 2 will give us 1.75. So our final answer for this is what? 1.75. It means our semi-interquartile range is what? 1.75. Okay, now let's look at measures of position. But this time around, we are going to look at the grouped data for the measures of position. And so quartile, decile, and percentiles, they have what? group data and ungrouped data, and before then we have already looked at the ungrouped data. So now we are going to look at the grouped data. And you know, group data, the data has been grouped into what classes with respect to their frequencies, right? And so these three items, they all share one formula. Do you get it? And we have already looked at the formula when we were talking about measures of variation, that is, sorry, measures of central tendency, measures of location and central tendency, that is median, right? So when we were talking about median, we realized we have L plus n over 2 minus cumulative frequency of the median class, the class preceding the median class, and the frequency of the median class, multiplying the class size or the class width, right? Okay, this same formula is what we are going to use, but one thing that is going to change from this formula is the n over 2 here. This n over 2 here represents what? 1 over 2 times n, right? Because we are dealing with median, and you know, if you have a distribution, median is the middle, so it means you have divided the distribution or the data by what? 2, right? That is why we say half. So half is multiplying what? The number of observation or the total frequency. Do you get it? So that is why you see half times n, and you know half times n, 1 times n will give you n over what? 2. So sorry, n over 2. That is why you see n over 2 here. So this n over 2 represents what? 1 over 2 n. Do you get it? So that is for the median. And now when we talk about quartile, we mean, let's say if we're talking about third quartile, we mean what? 3 over 4. So the same thing, third quartile, okay, 3 will be equal to the same L, which is the lower class boundary of the third quartile class, right? Plus there's the class. And so here, instead of 1 over 2n or n over 2, we are saying 3 over 4, because we are talking about third quartile. So 3 over 4 times n. This is 1 over 2 times n, don't forget. But this one will be what? 3 over 4 times n minus the cumulative frequency of the preceding class over frequency of the quartile class times your class size or class width. Okay, the same thing will apply to when you are talking about, let's say, 7th decile. So 7th decile 2 will be D7, the same L plus, this will change. Do you get it? So 7th decile is 7 over 10. So you get 7 over 10 times n, or 7 over 10 n minus cumulative frequency of the preceding class over frequency of that particular class, multiplying your class size or the class width. Okay, then when we are talking about percentile, percentile also uses the same formula, which is, let's say if we are talking about 60th percentile, that is P60, will give you L plus 60 over 100 times n minus CFM, that is cumulative frequency of the preceding class over frequency of that particular class times your class size or the class width. Okay, now before you calculate for any of these, you need to first check out for that particular class, because if you don't know the class, you can't just stand up and pick a class that you want and do your calculations. Okay, so you first have to calculate or find for that particular class. And how do you calculate for the class? What you do is always, the class is what you see here. The class is what you see here. Do you get it? So here it means before you start with the calculation, you have to first calculate for the n over 2. Do you get it? Before you calculate for everything. Now here to say, before you calculate for the third decile, you have to calculate for what? This 3 over 4 times n. Do you see that? So assuming you have been given a data and your n is, let's say, 50. Your n is 50. So you first calculate 3 here, 3 over 4 times 50. So 3 over 4 times 50 will give you what? 3 over 4 times 50 will give you 37.5, right? So 37.5. So 37.5 is the class that you are going to deal with. Do you get it? So you go to your cumulative frequency, then you check where this 37.5 will be. Do you get it? So from the cumulative frequency, wherever you see a number that you see of which you think this 37.5 will fall, that class becomes what? The class for the third quartile, or the class that you are going to deal with. Do you get it? So now let's quickly take a table or a group data, then we calculate for one of the quartiles, another for the decile, another for the percentile. Then we can say bye bye to measures of position. Now we are going to look at measures of position. That is our quartile, decile, percentiles. We are going to look at the third quartile from this group data, the 8th decile from this group data, and what? The 40th percentile from this group data. Do you get it? Already we have looked at how the formula is. So I think everything is going to be smooth and what? Very exciting. Okay, so now the first one is what? Q3, or the third quartile. So now let's first calculate for the third quartile. We know the formula, that is L. We know the formula, that is L plus 3/4, because it is third quartile, times our n minus cumulative frequency divided by frequency of the class times our class size, right? Okay, so now this L represents what? The lower class boundary of the third quartile class. Do you get it? And before you locate the class, unless you first solve for this, right? So we are first going to calculate for our 3/4 times n, and so this 3/4. Now what is the total frequency? We add everything here, 2. So we have 1 plus 4 plus 10 plus 14 plus 12 plus 6 plus 2 plus 1, and so that is 50. So we have our total frequency to be 50, right? So we can say 3/4 times 50. Now 3/4 times 50 is giving us 37.5, right? We are getting 37.5. So now this 37.5 is what we are going to look out for. After getting our cumulative frequency, we look at where this 37.5 is. Do you get it? Now mind you, this is what I said it in the previous video, that when you are calculating for anything that goes with formula, you first start from what? Your right hand side, right? So first you calculate for C. So now let's calculate for our C. This is the original table given. So our C is the class size or the class width. Our class size or the class width. So the class size or the class width, that is what? The difference between the class boundaries, or I said the vertical difference between what? The class interval. Do you get it? So, or the class limit. So this minus this is also what? A class size. Do you get it? If you subtract the two, this and this, if you subtract, that is a class size. Or you can calculate for class boundaries. After that, you find for the difference to get what? The class size. Okay, so now that is our C. So we are going to calculate for C here. We are going to calculate for C here. Then we calculate for what again? We look at the formula and see what the formula is demanding. Cumulative frequency. And normally we use what? Less than cumulative frequency. So cumulative frequency. And so now we are going to cumulate all the frequency. So the one will be here. We add this 4 to this one to get what? 5. We know it already. 10 plus 5 will give us 15. 14 plus this 15 will give us 29. 12 plus 29 will give us what? 41, right? So we are getting 41 here. Now 41 plus 6 is also giving us 47. Plus 2 is 49. And the last one is what? 50. Okay, so we are done with the cumulative frequency, right? We are done with the cumulative frequency. Now, this is it. The next one is what? Frequency. And frequency is already here. This one is the class that we have already calculated for. And this is what? Lower class boundary. So you can calculate the class boundaries. When you finish, you find for the difference to get what? The class size, or the class size straightforward. You can find for the vertical difference. So 159 minus 139 is what? 20. And so the 20 will be here throughout. Normally, the class size, they are what? Equal. Do you get it? They are equal. Okay, so now let's calculate for the class boundaries so that when we finish, we testify. Now, class boundaries. Class boundaries. Class boundaries. So our class boundaries, before we calculate for our class boundaries, we first calculate for the boundaries. Do you get it? So now how do we get the boundaries? That is what? The diagonal difference divided by 2, right? So 140 minus 139 divided by 2, you have 1 over 2, which is 0.5. So it means our boundary is what? 0.5. So what do? We subtract 0.5 from here and we add it to this one. So if you subtract 0.5 from this one, you get 119.5 to 139.5. Then you get 139.5 to 159.5. Then 159.5 to 179.5. Then you get 179.5 to 199.5. Okay, then this 199.5 will also come down here. 199.5 to what? 219.5. So 219.5. Then this one will also come down here. This one will come down here. So you have 219.5 to 239.5. Right? Then you have 239.5 to 259.5. Now this one will come down here. 259.5 to 279.5. Okay, so now we have been able to calculate for all that we need in the formula. Okay, so we said before you get the class size or the class weight, it is what? The difference between what? The class boundaries. So if you calculate for the difference, that is 139.5 minus 119.5. When you find for the difference, you are going to get what? 20. You are going to get 20 from here. It's the same thing when you subtract what? This and this. Do you get it? That is why I said always it's either you find for the difference between the class boundaries or you find for the difference, the vertical difference. Do you get it? They are all going to give you 20 throughout, because at this stage the class size or the class weight is always what? 20. Sorry, always the same. So if you get one number, you are going to get the subsequent numbers to be the same. Okay, so now we have what? When we calculated, there is the boundary. So let me clean it so that you don't get confused. There is the class that we calculated for. Do you get it? So that is 37.5. Now 37.5, let's look at the cumulative frequency and look at where the 37.5 will be. And so you see the 37.5 is located within this class. Do you get it? So it means this class is our third quartile. So we are going to use this class. We are going to use this class. Do you get it? So in an examination, if you don't want to get confused, you can deepen at this box. Do you get it? You can deepen it so that it will not skip you, or you can bring an asterisk to the side of that particular class that we are going to deal with. Okay, so now let's begin with our calculations. Let's begin with our calculations. We had 37.5 for the class, don't forget. So now the lower class boundary of the class, there is the class. And so what's the lower class boundary? 199.5. So we write our Q3 is equal to 199.5 plus this 3 over 4 times n is the same as the 37.5 we had minus this CFM represents what? The cumulative frequency of the preceding class. So you look at the cumulative frequencies. The preceding class is what? This. That is 29. You are not supposed to cumulate the frequencies, but rather the cumulative frequency. So the cumulative frequency, what they are trying to tell you is that, you see, this is the frequency of the class, right? So you have to cumulate all the frequencies preceding this class. And when you cumulate all these frequencies, is what you have over here. Do you get it? So if you add this to this, this to this, and this to this, you are going to get this 29. But you don't rather cumulate this cumulative frequency already. Other than that, we would have said something like cumulative frequency. Do you get it? So because it is cumulative frequency of the preceding class, we cumulate all the frequencies preceding the class. That is what we have here, 29. Okay, so we have 29 over the frequency of that particular class. So the class is what? 12. The frequency is 12. Multiplying the class size, and the class size of the class is what? 20. And so that is it. You put everything on the calculator to calculate for what? Your Q3. In case if you want to further with the calculation, you can say Q3. If it is theory and you want to prove or you want to show your steps, you can still go it by 199.5 plus 37.5 minus 29 minus 29 is 8.5, right? It's 8.5. So you have 8.5 over 12 multiplying with 20. Then you put everything on the calculator to calculate for your third quartile, right? So you have 199.5 plus 8.5 divided by 12, right? 12. Then you multiply it by your class size, that is 20. And so you have 213. Your third quartile is equal to 213.67. 213.67. And so you see, always our answer is for 213.67. So when you finish and you want to confirm that the answer that you have gotten is correct, what you do is come and check the class limit, whether this particular answer is located within this class limit. If it is less than this number, it means you are wrong. But if it is more than this number, it is also what? Wrong. So always have it in mind that your final answer must be within what? These two numbers. That is 200 to 219, of which it is very what? True. So that is it. There is the third quartile, the calculation for the third quartile. Let's quickly look at the 8th decile as well. The 8th decile. The 8th decile. Now for the 8th decile, the same formula. We say D8 equals L plus. Here will be decile is what? 10. So it will be what? 8 over 10 times N minus CFM over FM multiplying what? The C. Right? Now here we have to calculate this one first to know the class that we are going to deal with. So 8 over 10 times 50. This one is 5. So 8 times 5 is what? 40. Right? Okay. So we look through the cumulative frequency and see where the 40 will be. Do you get it? And still the 40 is within this what? Class. So the 8th decile, we are going to use this class for our calculations what? Again, right? But mind you, we are not going to get the same answer because in the previous calculations we had here to be 37.5, but here it is what? 40. But the parameters are going to be what? The same. Do you get it? Yes, sometimes you get a different class to also deal with. Okay, so now let's start with our calculations. L is what? 199.5 because the lower class boundary of the class that we are dealing with. So 199.5 plus 40 minus the cumulative frequency of the preceding class is what? 29 over the frequency of that particular class we are dealing with is 12, right? then we multiply it by 20. That is our class size. Then we put everything on the calculator, or you can see 199.5 plus 40 minus this one will give you what? 11 over 12 times what? 20, right? Okay, so you have 199.5 plus 11 over 12 multiplying 20. You have 217.83. So 217.83, and that is what our D8, the 8th decile, right? And is this number within this range? That is 200 to 219. So you see that number is within what? 200 to 219. So we are done with the 8th decile, right? Okay, then the next one is what? 40th percentile. 40th percentile. So for 40th percentile, it is also going to, we are also going to use the same procedure. So you can pause the video and try it yourself. So we have L plus 40 over 100 times N minus CFM over FM times what? C. Right? Okay, so this, let's first calculate for the class that we are going to do with. 40 over 100 times 50. This is 1 and this is what? 2. So 40 over 2 is what? 20. So the class that we are going to do with is what? 20. So let's check the cumulative frequency and see the class that we are going to deal with, right? So the cumulative frequency is here. Where does the 20 falls? Here, right? Yeah, so it means this time around we are not going to use this class, but rather what? This class. So let me clear the deep line so that we use the deep line for the next. Okay, so now because we are going to use the 20 is within here, so we are going to use this side. So let me rather deepen this side so that I'll bring the asterisk here. It means we are going to use this class, right? Okay, now we have the formula to be L plus 40 over 100, and we know the 40 over 100 is what? 20. We had 20, so L is the lower class boundary of the class, so this is the lower class boundary of the class, 179.5, right? So P40 equals 179.5 plus 40 over 100 and times N, we had what? 20, right? So 20 minus the cumulative frequency of the preceding class, it's now what? 15, right? It's 15 over frequency of this particular class is what? 14, right? So we say 14 times our 20, that is the class size. Okay, so now let's put everything on the calculator, or furthermore we say for P40 equals 179.5 plus, now this one will give you 5 over 14 multiplying what? 20, right? Now you see 179.5 plus 5 over 20, sorry, 5 over 14, right, times 20 will give us 186. So P40 equals 186.64, right? So let's check what we are getting. Is it within 180 to 199? Yes, our answer is what? True. So this is how we calculate for what? The group data for the measures of what? Position, right? So now we have something we call percentile rank, right? We have something we call percentile rank. So let's look at how to calculate for percentile rank. Okay, let's look at how to calculate for a percentile rank. Now for a percentile rank, we say it is your summation of the number of values below x, right? So number of values below x, right, then you add your 0.5, then you divide it by the total number of values. Then you multiply it by 100 since you are finding for the percentile rank. So that is it. So here, assuming you are being asked, today is an example, you are being asked to calculate for the percentile rank of 6. So you have to calculate for the percentile rank of 6. So percentile rank of 6, what are you going to do? We are going to first sum everything, these three numbers, before x, right? So that is 2 plus 3 plus 5, right? These are the numbers. Then we add 0.5 to it. We divide it by the total number. So we say 2 plus 3 plus 5 plus 6 plus 9 plus 11 will give us 36, right? So we divide it by 36 and we multiply it by 100, right? So that is it. So this will give us 10. The top will give us 10. This is 10, right? Plus 0.5, so 10.5 over 36 times 100. So 10.5 over 36 multiplying 100 is what? 29.17. Is 29.17. So this 29.17, since we want to calculate for the percentage, we multiply it by what? 100 to get what? Sorry, this actually, because we multiplied it by 100 already, it is what? Percent, right? Yes, I forgot to multiply it by the 100. So after multiplying it by the 100, the result itself is what? A percentage. So you bring your percentage. So this is how to calculate for percentile rank. Assuming you are to calculate for percentile rank of 9, the same thing, you add everything before 9, then you add 0.5 to it, just like this, then you divide it by the total number, you multiply it by 100. So that is all about the percentile rank. So in this case, we are done with measures of position and also the whole topic, that is measures of variation and relative dispersion. Once again, my name is Afari Ernest. See you in the next video. Kindly subscribe to our YouTube channel, like our videos. If you have any problem, put it at the comment section and our admins will make sure they attend to you. Thank you very much.